Okay, QNAME minimization. Here, let's say that I'm requesting for a COE DNS security dot in dot Asia. Let us assume that the domain name is COE DNS security dot in dot Asia, and the request goes to the recursive resolver, and the recursive resolver is not able to find the address resolution in its own cache. Then it of course is going to navigate through the complete DNS hierarchy to give a resolution to that address. And in that case, conventionally, the RR will send the complete domain name to the root, which is the topmost in the DNS hierarchy. So it will send the complete COE DNS security.in.asia to the root, and root will return to the return the address of the Asia name server. And when the RR again communicates the Asia name server, it will return the address of the .in name server, and the .in name server will be communicated by the RR, contacted by the RR, and the .in name server will return this COE security .in.asia address, right? So the idea behind QNAME minimization is to ask only for the name server of the immediate next level, meaning I ask the root for the name server of the TLD. So instead of sending COE.DNSSecurity.in.asia to the root, I just ask to the root where is Asia. I send query only for the Asia, and the root will respond me back with the name server address of the Asia, and the RR will again ask for .in to Asia. Instead of asking COE.security.in.asia, it is going to ask only for the .in to Asia, and Asia will return the .in, and then the RR can ask for COE security to .in, and it will respond back to this. So, at each level we are asking the resolution for the immediate next lower level of the DNS hierarchy. That is what is QNAME minimization. We have certain parameters for that. By default, the value is relaxed. QNAME minimization can be set to relaxed. Relaxed meaning it is the RR will send the complete domain name address to the hierarchy for resolution. If we put it as strict, then the RR will abide by the rule of QNAME minimization and give only the required next levels name to the name server's requirement to the higher level of name server, and get it resolved.
The next parameter is stale answer enable. If it is set to yes, if yes, it enables the returning of stale cached answers when the name servers for a zone are not answering. Means if the name servers for a particular zone are not answering, it will return the things. And the stale cache enable option is also enabled. So if you see this one more option is the stale cache enable. If it is set to yes, it will enable the retaining of stale cached answers. By default it is yes. So the stale answer enable also, it will enable the returning of stale cached answers when the name servers for a zone are not answering. And the stale cache enable option is also enabled. The default is not to return stale answers. So we have to set it to yes to get it working. Next option is clients per query. This is the minimum value, minimum or initial minimum value, minimum number of recursive simultaneous clients for any query that the server access before dropping additional clients. If more than 10 people ask for a query at a particular point of time, it will only answer to 10. The other questions will be dropped. By default, it is 10. So it is the minimum number of recursive simultaneous clients for any given query that the server accepts before dropping additional clients. And the next one is max clients per query. This is the maximum number of recursive simultaneous clients for any given query that the server accepts before dropping additional clients. The default is 100. The minimum is 10 and the maximum is 100 for this particular query answering. Now we will give a demo for that. Yeah, now we are configuring the options which we have specified. Yeah, uncommented, yeah, please. And now, since we have made changes in the server, we are again restarting the server. And checking whether the server is running or not. The server is running. So now if you see that only it is showing question section and answer section. Now there is one more option for enabling logging in this bind. So for enabling logging, we have to configure. We have an option of logging. So for enabling this particular login, we have to enable the query login, which we have discussed earlier. When query log is yes, then we can configure this particular logging. For enabling logging, we have to use a statement in this named.conf file. Logging statement we are using, which configures a wide variety of logging options for the name server. And this particular commenting, it will use various types of commenting. Like for single line comments, it is using / or hash, and for multi-line comments, it is using this particular thing. At startup, all logging messages open the user manual. See, now for enabling logging, first we are going to the location user local var name, where we have created the default directory wherein we are storing the information related to this server, and we are making a directory by name log, and we are opening the named.conf, which is the main file, configuration file of this bind server, and in that named.conf file we have to configure the logging using a logging statement, and this particular logging statement will have various channels and categories. If you see here in the user manual, it is having one channel is there by name default underscore log, and one more channel authoritative servers log, and it has various channels in that way. In addition to these channels, it also has various categories. So we have to set these particular channels and categories. And channels, we have to give the where it will store the information, location of the file, where it will store the information, and we are defining versions, till what versions it will store, and what will be the size of the files, like that. And we are telling various parameters for a print time, print category, and severity level, and various parameters we are setting for this particular logging facilities. And these channels, so in logging, we are basically logging statement consists of various channels and categories. So what are these channels? All log output goes to one or more channels. So since this particular logging statement has one or more channels, so we are telling that whatever output comes, it goes to one or more channels. And there is no limit on the number of channels that can be created. There is no limit. We can create any number of channels. The file destination class directs the channel to a disk file. We are giving the file location wherein this details regarding will go to a location and save the details of that particular information. The size option is used to limit log file growth. So we are giving the size option so that beyond that limit, it will stop. If we don't give the, if we are not giving, it will enormously grow. So we are giving the size option, so beyond that it will stop. The versions option specify how many backup versions of the file should be kept. So if we are giving a 3 versions, it will take 3 backups, like that. So by that we are giving the versions option specifies how many backup versions of the file should be kept. The suffix option can be set to either increment or timestamp. Increment means it will increment by 1, 2, 3, like that. Timestamp means based on timestamp that particular log file will be created. And it has categories also. Like channels, we have categories. It has all query transactions. So this particular category has an option of queries which will take all query transactions and query errors. Query errors, one type of category, we only all query failures. And security, one type of category wherein it will, the approval and denial of requests are stored are categorized into this particular thing. And expir in, expir out for zone transfers which are received and sending respectively. And the all errors related to DNSSEC validation are channelized into this particular category, DNSSEC. And RPZ response policy zone, one category. We have one sample logging file. If you see, this is one of the sample file wherein it is a logging statement is starting with logging, and here just 2 channels are there with the default location of the file and versions and size of that particular file, each file. So it will support till 600 versions. Here by for instance we have configured 600, till 600 versions it will support. And these are the other parameters which we have configured. Here we have given a category queries and category query errors. And here if you see, what for this category one channel is there, and for this category one more channel is there. And we will show the demonstration for this logging. We are uncommenting the logging file. We have created a logging wherein various channels and categories we have created. Since we have saving the file, since we have made changes, we are again restarting the server. Now if you see this,
we had several logs created here and we have removed all the logs now. When we restart the server, all these logs will be again created.
so now again if you see the whatever we have deleted earlier, I mean when we have run the server and we have set the logging option in the named.conf file, it has generated the various directories where it will store the details of that particular logs.
We'll just demonstrate a logging action happening. We have executed a query in which we have tried to resolve cdac.in, and the IP address which you see here 10.0.2.5 is the local host on which we are running the server, and you can see the queries file in which the queries are going into, and this is the entry which is done to the queries file. This is running the local host, so there is no traffic coming into it. This is the only resolution which has happened in this resolver after it has been restarted. So the queries file has just one entry in that, and it has been done today. Today's date is there with the respective timestamp, and it is queries, and the severity has been put as info. Any logging, I mean debug is one of the severity which can be indicated. We have put the severity in the info in the configuration file, so it is indicating a info severity here, and this is the client. This is the client from which the request has come, and this is the resolver IP, and this is the domain name for which the query had come, and it has returned the A address of that. I mean the IPv4 address of that. Okay, right. So here, to improve the performance of the recursive resolver, I'll just take back you to the one of the previous slides. Okay, fine. So in this slide, we just if we recollect, we can understand that any query that is coming to the recursive resolver, and if it is not able to resolve the query at its local cache, then it has to traverse this complete DNS hierarchy. And while traversing this DNS hierarchy, it has to obviously throw the first query to the root server, right? So if a query, any query coming to the recursive resolver has to definitely go to the root server for resolution if the RR's cache is not having the resolution with it, right? So the idea of RFC 7706, which was introduced a few years back was to cut down the traffic going to the root servers by running an instance of the root servers database at a low loopback address on the recursive resolver. So if we look at this diagram, so if the RR is not able to find the domain name resolution at its local cache in step 2, it looks for the root data in its loopback address. So by that it can cut down the visit it does to the root server instances. So by this we can protect any DOS attack or any attacks, because any query resolution which is not at the capacity of the cache of the recursive resolver to resolve it has to definitely reach the root resolvers, root instances. So root instances will be overloaded if there is an attack kind of thing, or many traffic will be coming to that root instance. So to cut down the traffic coming to the root resolvers, we can run a instance of the root database at a local host on our recursive resolver. Additionally, we are also reducing the total response time of this RR from the perspective of the client, which is asking for the domain resolution, right? Because we are cutting down one request and response cycle from the total request response cycles of this DNS hierarchy. By that, we are reducing the time that is taken for a single query resolution, and hence the effective latency will reduce. This RFC 7706 was overridden by another RFC in June 2020. Just now in June 2020, RFC 8806 was introduced, which made RFC 7706 obsolete. And we have implemented this RFC 7706 at our recursive resolver, meaning our recursive resolver, which is hosted at 223.31.121.171, is hosting a root database in its as a local service in itself. Right. So I'll just open the. Okay. So here in the CODNS security.in website, we have the publications, and under the publications we have two implementations of it. RFC 7706 was our earlier implementation, which we did in January 2020, and now we have revised it to RFC 8806, and the white paper describing the need for that and how to go about setting up RFC 8806 is hosted here. Right. Okay, right. So these are the root instances from which we can our recursive resolver, any recursive resolver can fetch the root database. So B instance is there, C instance, D, F, G, and K are the root instances, and these two are database instances. These are not root instances. These are database instances hosted by ICANN for sharing the root database of abiding by the rules of the RFC 8806. So in order to configure RFC 8806, we need to have the view statement in that, and we need to have the destination. Of course, it's a loopback, so we are giving the destination, and type mirror has to be specified because we are mirroring the database. And once we give this configuration and run our server, we can see that root zone.db gets created on our server. This root zone.db is the complete root instances database, which will be downloaded onto our machine. It may take few minutes depending on our machine configuration and the network connectivity to download that complete database onto our machine. Notify no implies whether my RR wants to be notified by the root instance of any update or not. By default, every 24 hours, this will contact the root instances and download the database, updated database. So this is the master list of this is the master list of this is the master list of the root instances from which the root database can be downloaded. So we have yeah, so we are going for a DNS sec validation, which is made auto, so it will automatically download the DNS keys for interaction among the between the DNS hierarchy and the recursive resolver instances, and allow recursion for any. We are public open resolver, so we are not restricting any whitelisting or blacklisting any of the clients. And this is the root zone, specifying the root zone, which is static. And where is the root zone hosted? Root zone is hosted on the loopback address at this address. So these are the required configurations to be done as part of to enable our recursive resolver for RFC 8806. And these are the root instances from where the database can be downloaded. So we had conducted a study, and we have compared the performance and documented as part of it. So I think we can now go for the demonstration, and in the demonstration we'll see how a thing works with or without this RFC 8806 implementation of that. So this is available in our website, available for download and reference. So we'll move to the demonstration of that. So this is named.conf. As we earlier saw that slash asterisk followed by a asterisk and slash is the multi-line comment utility as part of for this configuration file. We can I am removing this configuration file. I'm sorry, I won't be removing now. I'll just demonstrate. Now we have put the entries here. You can see here that we have the match destination here, and the root zone is there. We type mirror. This is the database which will get downloaded. The download database will be returned to our local machine with this name. We don't want any notification, and these are the root instances from which we will be approaching for downloading the database. And this is the recursive instance of the root. We have explained this. We have seen this earlier. So we'll just run this utility without the RFC being enabled. So here we have the again as discussed, we have the dig tool domain information gropper, and we are using localhost meaning this is the present machine on which we are running the bind server at 10.0.2.15. We are looking for trying for resolution of cdac.in, and plus trace is the option of dig tool, using which it will show the complete resolution track of the domain name resolution. So you can see here that this is the complete resolution which has happened. The query has gone to all these root instances, and it has received a response from the D root instance. D root instance has responded to that by providing the .in name server of .in, and that has again returned back from here. ns2.registry.in has responded, and it has given us the ns1.cdac.in address, right? So 3 hops have gone because cdac.in, and the in is followed by a hidden dot, which is not usually seen by the user. So this was the .in resolution, and this is the CDAC in resolution, and this is the CDAC.in resolution. So I'm uncommenting the commented lines, meaning I'm enabling the RFC on the recursive resolver now. Restarting the server, name the server, bind server.
So server is
server is restarted.
Again, we are running the dig trace to see the how the, and if you can see directly, so the trace is very less. No, it did not go to the all the root servers, since we have configured the root servers in this local server using the RFC 8806. So we just got the directly information from this.
Right. So we have okay. There was a point here by name zone statistics. So you can see here conf. So the zone statistics option, which we discussed in the presentation, is to enable a logging related to a zone which is specified in our configuration file. So here we have specified a zone CDAC.in, right? CDAC.in is the zone which we have specified, and we have provided the address of name server address of CDAC.in here itself. So the CDAC.in can be straight away resolved at the at our recursive resolver itself without navigating through the hierarchy. So if we have domain names which are trusted by us, and we want it to be resolved at our resolver itself without traversing the complete DNS hierarchy, we can specify them as zones under this options statement here. We have put the CDAC.in entry into this option statement. So if having enabled the zone enable the zone statistics here, all the queries related to the CDAC.in will be logged under this zone statistics category. Restarting the server. And we have got the resolution of the CDAC.in here. This is the resolved address of that.
So we have one more option called version, wherein by default, whenever we are checking the version of a bind server, it will give the version. But if by using this particular version, we can disable and make that so that it will not actually display the version of the software. We can give some customized name to that version. We are again restarting the server. So now if you see here, it is showing the version 9.16.6 is the version of this particular binder. And it is a big vulnerability, because if anybody knew this particular version of this bind, they can easily attack the server. There is a possibility, and this is a big vulnerability in the system. So we can disable that version. So we have version, and we have given forbidden. We have just given forbidden. We can give any name, whatever we want. Again, we have to restart the server. Now, if you can see this answer section here, it is coming as forbidden. Instead of the actual version of the bind server, it is giving forbidden. So anybody who is trying to find the version of the bind server installed, they will not be able to find, because it is giving the customized information.
Right. So I'll just run through the session again, and following that we can have the questions. So we had a look at the bind components. Bind is a DNS resolver software, and we had a look at few of the tools like dig for domain information gropper, and named-conf for verifying the syntactical correctness of the configuration file, and RNDC tool for remote control over the name server using for system administrators. Right. So this was the DNS general DNS query resolution, and we had a look at a few logging utilities. We can create a dump file. We can create a statistics file of the number of queries resolved, number of queries dropped, number of server fails. All these can be captured as statistics files. Mem statistics, memory statistics of our server files, and recursing files. The query which is under resolution recursively through the DNS hierarchy will be logged as part of this. So the idea of having these logging facilities is to we can do a forensics easier in a easier way to determine the any attacks which are happening can be tracked down and identified using these logging utilities. And we had managed key directories which had all the keys pertaining to the DNSSEC for interaction with the between the recursive resolver and the DNS hierarchy. And we had the session key between the primary and secondary servers. If we have we usually any server has a primary and secondary server, and to have a safer transaction between a primary and secondary server, we can have this stores the session key, which is transaction signature for that. We need to have a DNS sec validation for secure interaction between the recursive resolver and the DNS hierarchy, and by this we can also ensure that cache poisoning does not happen. Minimal NE is one of the performance enhancers. Suppose there is a DNS query asking for any record. So instead of any record, meaning in response to a DNS query which comes with a request for any record, the RR is usually built to respond with everything that it has related to that domain name. So instead of responding with everything that is related to that requested domain name, the RR will respond with minimal data. It will either select a record and send as part of the response to any request, or it can send a AA record, IPv6 record in response to that. A query log, we are trying to log all the incoming queries. Of course, it's necessary to determine, and if we have a proper visualization of query log utility in our of our DNS servers, we can determine the attacks happening using those visualizations if these query logs are coupled with a proper visualization tool. Zone statistics, we define a zone and we capture all the activities. We have a whitelist set of zones in our configuration file, and any activities that are resolutions happening with respect to that particular zone will be captured as part of this zone statistics. Minimal responses, meaning the RR responds only with the data which is requested. If a record is requested, it replies back only with the a record. If a txt record is requested, then it responds only with the txt record. If a CNAME record is requested, only a CNAME record is replied. Okay, so there's a small difference between this minimal any and minimal responses. So minimal response is answer to what is being exactly asked for, whereas minimal any is the query is for any record, but it gives the minimal response as much as possible. QNAME minimization. QNAME minimization, as we know that instead of asking the root for the complete domain name, it replies back with it asks the root for the TLD's resolution instead of asking the complete domain name. Similarly to the TLD, the RR will ask only for the STLD name server instead of asking for the complete domain name. So that is QNAME minimization. So by this we can cut down the packet size that is undergoing the transaction. So we have stale answer enabled, stale cache enabled, and clients per query maximum max clients per query. There is a concept of waiting service. Let's say that I have a network, and from a single network there are 100 queries coming to a resolver. It obviously means that it's a set of bots which are working to pull down the RR or so, right? So it means that by waiting service, the RR will identify that let's say that if 100 queries are coming, we give a particular value to this maximum clients per query, and if 100 queries are coming, it'll put the queries in waiting, resolve one query, and reply back to the remaining queries with the resolution instead of traversing the complete hierarchy for each request that it has received. Logging is very essential for any server for forensic sake and investigation sake. And there are this commenting facility is for any comment in the named.conf that we do. Is for any commenting facility that we have in named.conf / these are for single line and these are for multi-line. We have seen that already. So we have two concepts in the logging. One is the channels and the categories. Channels are the places where we specify what type of log, specify the names of the log files and the items which are going to be logged as part of that log file, meaning which destination it has to go, the size of that, the version of that, what will be the suffix, how do we do the rotation of the log, whether we make it incremental or we make it based on timestamp, and whether we are going for a time, client IP, what are the fields to be logged, all are specified in these channels, and that has to be mapped to specific categories which are defined as part of the logging facility in bind. So here are a few essential categories defined: queries, query errors, security, xref in, xref out, DNSSEC, and RPC are the set of categories, main categories which are listed here. And this is just a sample logging file. And coming to the RFC8806, this is to cut down the request which is going to the root, and we cut down the request by running a instance of the root database in our resolver as a local service. So instead of going to the root server for resolution, the resolution for the root for the TLD happens at the RR itself. So these are the references. We have manuals, software, bind 16.6 software at this link, and the manual for setting up the bind is listed here. The manual, which is part of this session, which we are handling, is hosted at this address, at this link, and the resolution for RFC enabling is hosted at this address, and the bind manual, which the bind community provides, is hosted at this address. So this is for the session today. So if we have any question or answers, we can take it up. Any questions? I think the participants can unmute yourself if you have any questions.
Yeah, good evening, sir. Can you hear me?
Yes, sir. Good evening.
This is Mukul Sharma from STPI.
Yes, sir.
Sir, I have a question regarding RFC 8806 standard. The basic concept is that you have actually run the database that was supposed to run on a root server onto your own recursive server.
Yes, sir.
So my question is, can any DNS server have that database, or is there any configuration done on the root in server also? I mean, is there any authentication method, or any DNS server can have the copy of the database of the root in server onto their own recursive server?
Yes, sir. If the configurations which are covered as part of the white paper which we discussed just now has those configurations, and there is nothing to be done in the root instances. If we have those configurations in our configuration file, it can connect to the root instances and download the databases.
But there is no registration or anything of the sort of our recursive server in the root server, or any domain name registration like that.
No, sir. No, sir. No, nothing of that kind.
Okay. Is there any compliance requirement that comes out of keeping the copy of the database of the root server?
Okay. Compliance meaning going for an agreement.
No, sir. In terms of technical compliance, that the DDoS attack and the
nothing
to be
of
addressed.
that kind, sir.
Okay. One last question, sir.
Yes, sir.
Is this a one-way communication? As far as the demonstration we have seen, it seems to be a one-way communication from the root in server. The database copy is being copied into the RR server. So is it the other way also? If there is any updation in the data in the caching part of the RR server, does that also reflect into the root in server?
No, nothing of that kind is required actually per se. But every 30 minutes there is a synchronization which happens between the RR server and the root instances, and the database gets updated if there is a difference, if there is an update.
But that too is a one-way communication from the root server to the RR server.
Exactly.
Okay. Okay. Thank you. Thank you very much.
Thank you, sir. Any other questions, sir?
Okay, so Thank you, Gopi, Shubham Goyal, and Venkateswamy for the informative webinar. We thank all the participants who have taken their valuable time and participated in this. Please feel free to get back to us if there are any queries. We also have a WhatsApp group of DNS security alumni. If somebody is not there, we'll try to add them. Anyway, the registration data is with us. We'll just add your things to you. If you are interested, you can continue to be in the group. So that is one thing. So I think if there are any questions, further questions which are coming up. Okay, so thanks all of you for being here. So as Gopinath has pointed out, please keep visiting our website coednssecurity.in, where we'll be updating the information. Also, this particular session will be available as well as the entire video also will be soon be made available. The presentation or used also will be made available to you in our website. And most importantly, I also want to point you to this particular email ID. Whatever mails that you think is a spam, please try to send it to us at this particular email ID, spam@coednssecurity.in. We are trying to create a data set which once it grows in size and quality, we will try to share it for people to carry out their own research. So that will be helpful to most of the people here. Okay, so that is another one thing. And second thing is, as Mr. Gopi would have pointed out, we request you to use our public DNS resolver. You can configure it as one of the DNS resolvers, either as primary or secondary based on your interest. And if you are using IPv6, you can use this address for configuring it. And whatever that has been taught today is also already implemented in this particular DNS, our particular DNS resolver. So with this briefing, I would like to thank all of you, and we'll meet soon with another interesting webinar. Thank you. Thank you so much.